Alright, welcome back to another episode of Coding with Culp. Been a while since I've done a Arduino video for you guys, so today we're going to take a look at analog input on the Arduino. Now I'm using an Arduino Uno. This will actually work with pretty much any Arduino. You might have to change the pin outs or pin numbers here or there, but the basic principle is exactly the same. So let's talk real quick about what analog input is. We've already done digital input. In digital input, you essentially only have two values. The value can be either be on or off. It can be a 0 or a 1. The push button that we used was an example of a digital input. So when we pressed a button, we received a digital 1, letting us know that the user had pressed a button. If the user wasn't pressed or the button wasn't pressed, then we would read a 0 in that particular port. Analog input is a little bit different. It can actually have a range of values. It's such things as, say, a light level sensor that tells you the level of light in a room. That's a range of values. And on our Arduino, that range can be from 0 up to 1024. And so when we read that analog input, it's going to give us a number between 0 and 1024. We're going to take a look at two different analog inputs on the Arduino today. Right over here we have what we call a potentiometer. They come in a lot of different sizes and shapes. I'm dealing with the Elegoo Arduino Uno kit, which is an awesome kit for I think $50. You get the Arduino Uno, everything you need, cables, tons of sensors, and other things to hook up to the Arduino. So we're going to take a look at analog input with a what's called a potentiometer, and also with a photoresistor, which is going to read the light level in a room. A potentiometer is basically a dial, and we can read that input from the potentiometer, and it will essentially tell us the position of the dial. What we're going to do with both of these is we're going to light up an LED. And the LED is going to be a different brightness level depending upon what it's reading from our analog input from either the potentiometer or the light level that the photoresistor is getting. I'm going to do things a little bit different today also. Normally what I used to do is I would write the program line by line. This time I'm not going to. I'm just going to show you the program and then tell you how it works. That'll shorten the video a little bit. In addition, I also usually go over to my workbench and I physically build the circuit. And I think you should have enough experience now, if you've watched my other videos, that you can take my drawing and actually build the circuit yourself on your breadboard. I'll point out a few things you need to watch out for, but I don't think I need to do that. If you think I do need to do that from now on, just let me know in the comments below, and on the next videos I will build the circuit on camera for you. So let's take a look at the circuit we're going to build. The first circuit, we're going to do this 2 times. There we go. Yeah, this is what I'm looking for. So we're going to do this twice, once for the potentiometer and another time for the photoresistor. So the parts you're going to need is of course your Arduino Uno, and you're going to need a 10K potentiometer. It's going to look like a little dial in your kit. Let me see if I can take it out of my circuit here. There we go. So it's going to look like, I hope you can see this, it's going to look a bit like this. It's got 3 little legs or pegs on it. Whoops. Oh. 3 little legs or pegs on it. And it's also going to have the word, and I doubt you can see it, it's going to say 10K right on it. Alright, let me put it back in my circuit so my circuit works. Alright, let me see if my circuit still works. I think it is. Okay. The other thing you're going to need is a 220 ohm resistor. Now going by color codes, if you've got a standard 4 4-band resistor. Your colors are going to be red, red, brown. And then, of course, this fourth band is for the tolerance, and we don't really care about that. If you're using a 5-band resistor color code, those resistors are usually blue in color. It's going to be red, red, black, black. All right. So here's how we're going to hook this up. First off, we're going to build ourselves just a standard LED flashing circuit. So notice in my breadboard, I put the LED up here. Right here is the anode. That's the long pin right here. And from the anode, I have my 220 ohm resistor, and notice I jump the middle area, or across the middle area with the resistor, and then I run a wire from the same row that the resistor is in over here, and that's not correct, to pin number 6 on the Arduino. Now in reality, it doesn't matter which pin that we use. Well, okay, it does matter which pin that we use. However, we just need to use a pin that's capable of PWM output. Remember, PWM can vary the voltage level. So instead of just being on or off, it can be in between. And those pins have a little tilde right there. And so for this one, it's 3, 5, 6, 9, 10, 11, etc. I chose pin 6, and my code is going to use pin 6. Now then, we have to hook up the cathode to ground. And what I did was I ran a ground wire from ground right to here. Because now remember, everything, in fact, this is what it's showing with ground there, everything in this row is going to be connected to ground now. So then I just run a wire from here, and notice I'm on the other side of that bridge, or other side of that gap, and I run it down to this row right here, which is the ground row, because I now have a connection to ground on the Arduino. So that's going to set up our standard LED circuit. Then we need to hook up the potentiometer. Our potentiometer has 3 legs on it. 1, 2, and 3. And I have this hooked up incorrectly on here. Let me move it. Okay, there we go. Our potentiometer must bridge this gap. Okay? Okay. It doesn't have to, but I've got it so that it does. I think it just is a bit easier. This left leg right here is going to connect to ground. So notice I'm in the exact same column, because every column connects. So this 1, 2, 3, 4, 5, all 5 of these have a connection together. All 5 of these have a connection together. All 5 of these have a connection, etc. So this right here is being run all the way down here to ground. Because remember, I plugged my ground wire into here. So this has a connection all the way through here to ground. Then this one right here, the leg on the right, is going to run all the way around, and I hooked it up to 5 volts right here, the 5V pin. Now in reality, yours isn't going to be straight and then, you know, make a 90-degree angle. Mine looks like a rat's nest over here, sitting over here. But you know, however you need to run from here. So it's got a connection with this pin on the right, with this leg on the right, and it goes to 5 volts. And then finally, this pin right here, this leg, is your output. And notice, basically, I run a wire from that same column that the output pin is in, and I run it over here to A5. A5. These are our analog pins. Okay, these are our analog pins. And we can plug in analog sensors into our analog pins. So go ahead, hook up, build this circuit. Be very careful, double and triple check everything. I'll show you the entire, there we go, there's the entire circuit. So pause the video, go build it, and then we're going to take a look at the code when you come back. All right. I'm assuming that you paused it, and we're going to go take a look at the code now. Let me see if I can make this bigger. Edit. Increase font size. Control plus. Okay. Still want to have the entire code on the... Okay. So what I did up here is I set variables for our 2 pins. The LED pin was in port number 6, or pin number 6 on the Arduino. And the potentiometer pin, pot pin is what I'm calling it, but notice there's an underscore. We put in A5, analog 5. Notice I've got the semicolons. Then in setup, that's where I, set up my pins. I set pin mode LED pin to output and pin mode pot pin to output. And I'm going to be using the serial port because I want to print out some values. And so I start my serial port at 9,600 bits baud. Now remember, loop is where it loops. Okay? And, I don't need this stuff anymore. Let's get rid of some of the stuff. It was left over from something I was doing before. But we don't need it anymore. Okay. Inside a loop, I've got some stuff commented out, these 2 things, because I want to show you something first. The first thing I do inside a loop is I declare a variable, and I'm going to call it pot reading for the reading on the potentiometer. And if I wanted to, in fact, I think I'm going to take it out. I'm going to put it up here just for the heck of it. I know I'm changing code around on you. All right. So this is our variable, pot reading. I set it equal to analog read pot pin. What that's going to do is it is going to read, okay, the potentiometer and give us back a value from 0 to about 1024. Sometimes it won't go all the way down to 0, and sometimes it won't go all the way to 1024, but that's okay. So pot reading is now going to be equal to between 0 and 1024. Don't worry about these 2 lines that I have commented out right now. We're going to put them back in just a minute. But now all I'm going to do is I'm just going to print out our value that we're reading. Okay. Print a new line so we go down to the next line. And then delay a bit. Okay. And then it's going to go back up and do it all over again. So let's go ahead and download. And once again, before you download, a couple of things to make sure of. Number 1, make sure you got your board set to Arduino Uno or whatever it is that you are using. And make sure you have your COM port set. So I'm going to upload this. Okay. Should be running. Mine's running. What I'm going to do is I'm going to go over here to Tools, Serial Monitor. And that's going to print out. So there we go. Right now our value is 0 because I have my potentiometer turned all the way to one side. Now, the potentiometer in the Elegoo kit comes with a little handle that you plug in. I have lost that handle. It's a little plastic peg that you plug into it to use it as a handle to turn the potentiometer. I've lost it. I am using a really sharp knife, a razor knife, but I'm going to turn my potentiometer. And let's watch what happens as I turn it. You can see the values are starting to change. And so there we go. That's the maximum value. So we're getting up to about 1007, 1008. We'll call it 1007. Then I'll turn it the other way, and it turns it down. And up and down, up and down. So we're absolutely reading our potentiometer. But now we got to connect it up to the LED so that our LED varies in brightness based upon how we have the potentiometer turned. Well, here's a problem though. Let's just come over here to analog write. I'm going to uncomment that code there because there's something I want to show you. Analog write, okay, takes the pin number to write to, in this case LED pin, and then a number between 0 and 255. Notice there's a problem. Okay, we can't just plug in the pot reading, okay, into there because analog write's expecting 0 to 255, but pot reading can go all the way up to, in our case, 1008. So our range is vastly narrowed. There's a couple of different ways we could do this. Maybe we could divide pot reading by 4, because 1024, 1008 divided by 4 will roughly give us a maximum range of about 255. But that doesn't work very well. On the Arduino, there is a function called map. And what map does is it takes a value, okay, a number, in this case pot reading, and we tell map the low value of that reading and the high value. I'm going to change this to 1007 because that's about what we were getting. And then we tell it what low and high value we want to map it to. So we want our low value to be 0 and we want our maximum value to be 255. And then we reassign that back to pot reading. So once again, what we're going to do is we're going to use the map function. And the map function takes a value, a number. In this case, it's going to be our pot reading. That's the first thing we pass to map. Then the next two numbers are the lowest value that pot reading can be, which is 0, or the lowest value that whatever this number is can be. In our case, it's 0 for pot reading. And the highest value that number could be. In other words, the whole range that number could be in. And for us, it's 0 to 1007, somewhere around in there. Okay? Then the next two numbers it takes are the new range. And in this case, it's going to be from 0 to 255. And so now, pot reading will be scaled to 0 to 255, and we can use it in analog write. So I'm going to download this, and I know you can't see this. I don't have a camera. I need to get a camera to put on here. But now, oh yeah, let me come over here to Tools, Serial Monitor. Okay, so I've got it at 0, and in fact, my LED I can see is not on. And then I'm going to slowly turn it, and you can see it starts to go up, and, oops, other direction. Okay, there we go. And it starts to go up slowly. My LED is barely on now, and it starts to get brighter and brighter. And then you'll notice I can't go above 255, and I've got it pegged out, and it's staying right about 255. Now, one of the problems with LEDs and doing this with LEDs don't really have a good linear response. You'll notice on your LED as you're turning your potentiometer that there comes a point where it's about medium, intensity, and then you turn it just a tiny bit more, and boom, it's fully lit. And that's because LEDs, or at least these, don't have a good linear response to voltage. All right, so that's using a potentiometer. Now what I'm going to do, I'm going to come back in just a minute. I'm going to rebuild this circuit and show you how to use another type of analog input, which is a photoresistor. It's going to react to the amount of light that we put on it. So I'll be right back. All right, I'm back, and I've got everything set up for using a photoresistor. So what we have here is the circuit that we're going to build. Now, this right here, this is the circuit for the LED. It stays exactly the same. Exactly the same. What you're going to need to build the circuit, this right here is a 10 kilo ohm resistor. Now, if you're using a 5-band color code, a blue resistor, you're going to look for brown, black, black, red. Brown, black, black, red. If you're using a 4-band color code, you're going to go with brown, black, orange. Brown, black, orange. And then you're going to need a photoresistor. Your photoresistor is going to look like, I don't have an extra, I know what to do. In my little title screen, I've got one that's going to look like this right here. It's going to look exactly like this right here. Alright, so let's go back to building the circuit. Now this gets a little bit complicated, so I need you to follow along very, very, very carefully. The first thing I want you to do is put in your photoresistor. So I've got one leg here and the other leg here. It doesn't matter, this isn't polarized, so there's no anode or cathode or anything like that with a LED. On one of them, you are going to run a wire to A5. That's analog 5. It's exactly the same analog port that we had for the other circuit. We're going to read it. In fact, our code's going to stay almost, but not exactly the same. The other leg, you're going to run a wire to 5 volts. Now, in order to do this, we have to form what's called a voltage divider. So what you're going to do is you're going to take that 10K resistor, the 10 kilo ohm resistor, and you're going to put it right across here so that one leg is in the same column as the column going to the analog pin. And then the other side, you're just going to run it down to ground. Remember, we made a ground connection right here because everything here is connected to ground. So we've got a ground connection right here. Now we're ready to look at the code. So I'll give you a few minutes. Go build the circuit, pause the video, and when you're ready, come back and take a look at the code. The code's going to be almost exactly the same. So come back in just a minute. All right. Let's go take a look at the code. You're going to notice the code is almost exactly the same. We're going to set a LED pin to 6. Pot pin, let's not call it pot pin. Let's call it photo pin. Photo pin equals A5, so we're going to set it to analog 5. And instead of pot reading, we're going to call it photo reading. We're going to set pin mode LED pin to output. And we do not need to set, believe it or not, we do not need to set the pin mode for the photo pin. So I just commented that out. We're going to start our serial port. And over here, the main loop is going to be exactly the same, only we're going to change everywhere we have pot pin to photo pin. Okay, and just like the other one, before we do this, I'm going to comment out where we actually map the reading. And I'm used to comments in Python there. Okay, so now I'm just going to read it and print it out. Let's see what our readings look like. See if I even got this right. Okay, tools, serial monitor. All right, so I'm going to put my hand over it, and you'll see the number gets much, much, much lower, much lower. Then when I remove my hand, it gets higher. Then let me see if I got my iPhone. Where's my iPhone? What did I do with my phone? I want the flashlight in my phone. Hang on. Just had the thing in my hand like 2 minutes ago, just before I did this video. Ah, there it is. All right, I'm going to turn on the light on my phone. So there we go. Let's put it over there. Oh, look at that. It gets super high now. We're up to, once again, that kind of top range. So we're flipping between 1006 and 1007 right there. And then when I take it away, we're back down to that mid-range 500. I'm going to put my finger completely over it, and we're down to sub 200. So now, once again, we're going to map that range. Photo reading. We're going to map photo reading. Our low value should be around 0, but I'm going to put it about 200. Let's put it around 190. And the high value is right around 1007. And we're going to map that to a value of 0 to 255. And then we're going to write it. We're going to write that value directly to the LED pin. And I know you can't see it. Once again, I don't have a camera to do that. I need to get one. And my LED is about medium brightness, which is what we kind of expect. And when I put my hand over it, it gets much, much brighter. Much brighter. Or excuse me, when I put my hand over it, I'm sorry, it gets dimmer. Yeah. And then when I put my light on it, let me get back to here, it should go way up in brightness. because remember when I had it, when I had the light over there, it caused the brightness values to go up. So yeah, my LED's at maximum brightness right now. In fact, if I come over here to Tools, Serial Monitor, we should be getting right around 255. Yeah. And then when I take it away, we should get about a medium range, yeah, about 100 and something. Put my finger over it, we should get very close to 0. Oh, we're getting negative values. And that's just simply because I don't have this this set right. I should really make this probably 0. All right, so that's it. And I kind of forgot to explain it. Basically, what's happening is we're actually reading the resistance, both the potentiometer and the photoresistor have a variable resistance. The resistance changes. The potentiometer, the resistance changes based upon where we have the dial set at. Whereas the photoresistor changes based upon the amount of light falling on it. Now, here's a challenge for you. Right now, our light kind of behaves backwards from what we would probably want it. It's brightest when the light falling on it is brightest, and it is darkest when the light falling on it is, well, the least. So if I were to turn out the lights in here, my LED would probably go out simply because it would have very little light falling on it. And then when the light's on, when it's brightest, the LED is the brightest. Can you figure out how you would make it so that reverses? So that when the light was brightest, our LED is the dimmest, and when the light is the dimmest, our LED is the brightest. So see if you can figure that out. I'm going to give you the answer here in just a minute, but pause the video. There's a super simple change you have to make. You don't even really need to do much other than change 2 numbers. So pause it, see if you can figure it out. All right. Really all you got to do is map this to 255 to 0. And it should work. I haven't tried this out, so I might be embarrassing myself. But let's find out. All right, let me go to Tools. Let's go to Serial Monitor. So used to, when I put my hand over it, the value should go down. Now if I put my hand over it, it still goes down. Still not working right. Okay, there we go. Yeah. Now when I put my hand over it, I had bumped a wire is what was going on. Now when I put my hand over it, it goes up, which is what we would want. And so as it gets dimmer, my LED goes up. Now let me get my light here. There we go. And let's put it over there, and it should go down now. And it does. So there we go. So now my LED is pretty much completely off because it's got a bright light on it. And then when I remove that light, it goes back up. And then if I put my hand over it, it's going to go up even brighter. Okay, that's it. It works. I hope you enjoyed the video. Hope you learned something in it. Please subscribe. I would really, really appreciate it. Like the video. If you've got any comments or questions, put them down below. I'll try to get to them. Until next time, every day is a great day to learn how to code. Bye-bye.